All right, we're going to go back and do some proofs for this video here. And what I'm going to do is we're going to be proving the isosceles triangles theorems. So we already know these facts. We've been using these facts, but now we're going to go through and prove that they're true. This one here, we're going to prove that just because we're given the two congruent sides on an isosceles triangle, that we have the two congruent base angles. We're going to prove that. And then over here, given that my base angles are congruent, we're going to prove that the legs are congruent. Okay, let's go ahead and dive in. There's a couple pieces that we're going to be learning new as we go through these proofs, but they should make sense. Okay, so this first one, setting up my proof, I'm going to go ahead and start with my given information. So here, the statement I'm going to make, I know that QR is congruent to SR. And I know that because it was given. So the reason I know it, that was given to me. All right, this is where we're going to start with our first new piece of information, because if we look at our triangle, I don't have anything else new to say. I know those two sides. I know nothing else. There's nothing. So what I'm going to do is I'm going to introduce a new line. I'm going to connect R to our base QS with this line, and I'm going to say that this is M, just for fun. I don't know, it's just a letter. And I'm going to say that this side, my new line RM, is perpendicular to QS. All right, so I'm going to make that statement. Side RM, this line means perpendicular to QS. The reason I know that is because I made it so. I created it. I constructed that perpendicular line. So now I can use that line with my proofs. Now I have two triangles, this side and this side. So two triangles, and what I'm going to do is I'm going to prove that those two triangles are congruent. How? If we look, we know that RM is congruent to RM because it's the same line. It's shared by those two triangles. So RM is congruent to RM because of the reflexive property. It is congruent to itself. And now I have two congruent triangles. I know that QMR is congruent to SMR. So I'm going to say triangle QMR is congruent to triangle SMR. The reason I know this, if we look, I know this angle is 90 degrees because we're perpendicular. I know they shared this side, RM, and then the hypotenuses here are congruent. So that is side-side angle. But if you remember in a previous video, I said that we can't use side-side angle. We either have side-side-side, side-angle-side, angle-side-angle, and angle-angle-side. This isn't one that we can use. Remember, no swearing and no screaming. This doesn't work. The only time the side-side angle works is if our angle is 90 degrees. So if angle is 90 degrees, which we have here, we actually change the SSA into HL, hypotenuse leg. We only have a hypotenuse when our angle is 90 degrees. So I know my triangles are congruent because side-side angle, my angle is 90 degrees. So that is by the hypotenuse leg congruency. Okay? So again, no swearing, but HL. So that's one twist here. The last twist I'm going to throw at you is, I know my triangles are congruent. Congruent triangles mean everything's congruent. Every corresponding part is congruent from triangle A to triangle B. So if they're congruent, that now means that my angle Q is going to be congruent to angle S because they're in the same position. They're corresponding. All right, so that means angle Q is congruent to angle S, and I'm going to shorthand this to CPCTC. And I'm done. But let's explain what that means here for a second. My CPCTC here, this piece is saying corresponding parts. Corresponding means they're in the same position. So corresponding parts of congruent triangles. So if my triangles are congruent, my corresponding parts are congruent. Can't see that. Let's duck a little bit. Here we go. It's a little bit better. So here I can see CPCTC. Corresponding parts of congruent triangles are congruent. If my triangles are congruent, every piece is congruent, so my angles are. All right, this side is just the reverse. Now we know the angles are congruent. I need to prove that the side lengths are congruent. We're going to do it pretty much the exact same way. Okay? So my video's getting a little bit long, so I'm going to go ahead and hustle through this. Make sure that we understand. So starting with the given, angle J is congruent to angle L. That has been given to me. I'm going to go ahead and I'm going to introduce my line that is perpendicular, and I'll call this again M. So line KM is perpendicular to JL, and that is by construction. I made it. Now I know that KM is congruent to KM because of the reflexive property. And now I know my triangles are congruent, but this one is angle, angle, side. Angle, angle, side. So triangle JMK is congruent to triangle LMK by angle, angle, side. So that means side JK is congruent to LK because of CPCTC. Okay, proving our isosceles triangle theorems. If you've got questions, let me know. We'll have another video that just goes over proving triangles are congruent. We can still use CPCTC. Just come back, check out my videos.